Okay, so today we're going to be talking about the assignment operator and objects, and that will lead us to the topic of aliasing. And then once we know what an alias is, we can talk about memory versus state equality. It may not be obvious at the beginning why we're talking about this and its relationship to conditionals, but hopefully by the end of the lecture, it'll be clear how these topics relate to conditionals. Okay, so let's start by talking about the assignment operator and objects. So when I say the assignment operator, I just mean the equal symbol. And the assignment operator is probably the first operator that we encountered this semester. And the assignment operator has a very simple job. So it copies the value on the right-hand side into the memory location on the left-hand side. And the assignment operator functions this way regardless of whether you're working with primitive variables or reference variables. Okay, so regardless, it always takes whatever value is provided on the right-hand side and it copies it into the variable, i.e. the memory location on the left-hand side. So what I want to do here is I want to take the same piece of code first with primitive variables and then with objects, with reference variables. And I want to look at how the assignment operator itself is not different, but the implications of the assignment operator are different, whether we're working with primitive or reference variables. Okay, so I'm going to write out a very simple piece of code with primitive variables. Then we'll look at kind of that same piece of logic, but this time with reference variables, and we'll see how they differ. Okay, so let's just say that we have some integer variables. So I have int num1, and I'm going to initialize it to a value of 20. Then I'll create a second integer variable, num2, and I'll set it equal to num1. And then I'm going to change the value of num1 to 80. So when I said earlier that the assignment operator copies values on the right-hand side into the memory location on the left, I just meant this. So this is the assignment operator. It's just going to take this value 20 and copy it, right, or store it in the variable num1. Okay, so this is a pretty basic piece of code, and at this point in the semester, we should kind of understand what's happening. There's not much here. But my question is, if we were then to print out the value of num2, what would we see printed to the screen? Okay, so you should pause this video and make a guess. If we were to print, so system.out.print num2, what value would we see printed to the screen? Okay, so there's two answers that you could give to this. So the first answer is that when we print num2, we'll see the value 20 print to the screen. And that's because when we created num2, we set it equal to num1. And at that point in time, num1 had the value 20 stored in it. Okay, so then when we print num2, we should see 20. I think the other reasonable answer is 80. Okay, so the rationale for that would be that, again, we set num2 equal to num1. So if we change the value of num1 and these two variables are equal, then we should see num2 also equals 80. Okay, so those are kind of probably the two most reasonable answers. Okay, so in reality, the answer is 20. Okay, so if we were to print out num2, we would see the value 20. Okay, I want to take this same piece of logic and I'm going to rewrite it, but this time instead of using integers, which are primitive variables, we're going to be using a reference variable. So far, we've seen three types of reference variables. We've seen the string class, we've seen the scanner class, and we've seen the random class. And today we're going to see our fourth example, which is the die class. And the die class is a class that I wrote myself. And it's something that in future lectures, we're actually going to spend a lot of time talking and analyzing the die class. Okay, so before I kind of rewrite this code, but using reference variables, let's just quickly look at the die class and see how do we actually use it. So, okay, so this is a class that I wrote myself, and what I'm showing you here is the web page that describes basically everything you need to know in order to actually use the die class. So this class represents a single n-sided die. The top number of the die is called the face value, and I'm showing that here. So when you have, this is a 6-sided die, and when you have a die, you roll it, and then whatever number lands on top, that's called the face value. So this die here has a face value of 3. So for my Java class that I wrote, you can either roll the die, so I have a method that simulates rolling the die, or you can just explicitly set the die to some particular face value. I have 2 ways of creating a die object. So you can just say new die and not pass anything in between the parentheses. This would create a 6-sided die with an initial face value of 1. Or you could say new die and you could pass in an integer, and then it would create a die with that number of sides. So if you passed in a 10, it would create a 10-sided die whose initial face value is 1. These are the methods that I added to the die class. So I guess most importantly, this is the roll method. If you call roll, it gives you back an integer, and that's the new face value. You could also just call set face value, this method here, and pass in an integer. And that will just explicitly set the face value to whatever number you pass in. There's also a method called get face value. This returns the current value, the current face value of the die. And then two other methods, so equals. So this method actually takes in another die, and it checks if the 2 die are equal. Okay, and do I say, yeah. So I just clicked on the equals method here, and this gives a little bit more information. So this method compares this die to the other die. The result is true if both die have the same number of sides and the same face value. And I came up with that. To me, the person writing this class, it seems like if you have 2 die and they have the same number of sides and the same face value, then they're equal. So notice that the equals method actually returns back a Boolean true or false. Last but not least, we have the toString method. This returns back a string, and the string summarizes the state of the die. And when I say the state of the die, I mean the string tells you how many sides the die has, and it tells you the current face value. So you can call this method and it returns a string, and then you can print that string. And then you can kind of inspect the state of the die. So this is a method, or sorry, a class that I wrote myself. And we're going to use this, and actually in the next lecture, we're going to be dissecting this class and kind of looking inside to see how it actually works. But for now, this is all we need. So we need to know how to create the die, and then once we have it, what methods can we call? Okay, so I'm going to now rewrite this code here, but instead of using integers, let's go ahead and use die. So let's create a new die. So I'll call it die d1 equals new die. From the documentation we saw, this will create a new die that has 6 sides, and it has an initial face value of 1. Okay. Now let's go ahead and create a second die. So die d2 equals, and just like we did over here, we'll set it equal to d1. Then we'll change d1. So let's say d1 dot set face value and we'll set it to 4. And just like over here, the question then becomes, if I was to print out the face value of D2, what would print? Okay, so if I said D2 dot get face value, what would print? If you remember from the documentation, this method just returns the face value. So it returns an int. We're going to take that integer and just immediately pass it to system.out.print. Okay, so the question becomes, what would print here? Okay, would we see that D2 has a face value of 1? Because when we created D2, we set it equal to D1. And at the moment we set them equal, D1 had a face value of 1. Or will we see the number 4 print out because we set D2 equal to D1, and then we change the face value of D1. And so that will change the face value of D2. Okay, so that's the question. We know the answer if we're working with primitives, and the question is, what's the answer if we're working now with reference variables? So I want you to pause this video and make a prediction. Do you think we would get a 1 printing out, or would we get a 4 printing out? Okay, so I'm actually not going to tell you what prints out. Instead, we're going to draw the effect of this code on in memory, and then we'll answer the question that way. Okay, so here's both of those pieces of code, and I'm going to step through and show you what happens in memory after each line is executed. Okay, so we begin here. So we have a new variable, num1, and we're setting it, or we're initializing it to 20. Then we create a new variable num2, and we take the value in num1 and we store it in num2. So here's me creating the variable. The value in num1 is 20, so that's what num2 gets initialized to. Okay, then I overwrite the value in num1 by setting it equal to 80. And just like we saw before, if we were then to print out the value of num2, we see that 20 would print to the screen. Okay, so let's do the same thing with our die. So we create a new die D1, and I set it equal to this object here. So again, we're gonna grab some memory, create a die object. I'm representing that object with the circle here, and it has an initial face value of 1. And what gets stored inside of D1 is actually the memory address. So this is 1200. Then we create another die, D2. And we initialize it to whatever value is stored in D1. So we take the value stored here, and that's what we're initializing D2 to. Okay, so when we look in D1, we see that the value is a memory address. So we're going to take this memory address and we're going to copy it into D2. What does this mean? So D1 stores the memory address 1200, so it points to, or it refers to, this object. And now D2 also stores the memory address 1200. So D2 also points to or refers to this object. So that when we say D1.setFaceValue 4, right, and we call the method and the method changes the face value, I'll do this in red, I guess. So it's now 4. If we were then to print out the face value of D2, we would see, right, following the edge or the arrow, right, we would see 4 printed out. Okay, so the behavior we see when we're working with primitives is quite different from the behavior that we see when we're working with reference variables. With primitives, right, when I change num1, that change is not reflected in num2. They have their own copies of the number 20. And so I can change num1 and it doesn't have any effect on num2. Contrast that with reference variables, it is true that they both have their own copy of the memory address, but what that means is that they're pointing to the same object. So I can change that object using D1, and that change will be reflected in D2 because it's the same object. Okay. So when we have two reference variables, that store the same memory address, memory. Okay, so two reference variables that store the same memory address are called aliases. So we say that D1 and D2 are aliases of one another. And this word alias has the same meaning that it has in English. So if you have like a spy who has, multiple passports and each passport has a different name in it, right? Those names are all aliases of one another. It's the same person, but this person has, depending upon the passport, they have a different name. In the same way, there's just one object here, and we have multiple names that we can use to refer to that object. We could use D1 or we could use D2. They're aliases of one another. Okay, so to summarize all of that, or maybe to say why are we doing this, I want to make it clear that when you use the assignment operator, although the assignment operator does the same thing regardless of whether it's primitive or reference variables, the effect on reference variables is quite different because reference variables store memory addresses, because there's this extra level of indirection with reference variables. Okay, so that leads us to this notion of memory versus state equality. And when we're working with a primitive like an integer, and we want to apply an equality operator like equals equals or not equals, basically all we have. So I could have an integer like age, and I could say, if age equals 20, right? Now, in terms of actual symbols type, that would be if open parentheses age equals sign 20 close parentheses, right? So when we have primitive variables, we have the equality operator, and then we have like this not equals operator. But when we have reference variables, we actually have two different ways to ask if two reference variables are equal. So we could ask if two reference variables are equal using the equality operators. Okay, so equals equals checks if two values are the same. And again, that is true if the two values are integers. It's true if the two values are memory addresses. Not equals checks if two values are different. And that's true if they're integers. It's true if they're reference memory addresses. Okay, so again, these operators don't change depending upon whether you have primitive or reference variables. So here's an example of using kind of equals equals with reference variables. So again, let's say that we created our die D1 and equals a new die. And then I create a die D2 and I set that equal to D1. And then I ask, right, if D1 equals D2, and if that's true, let's say that we do something. Maybe we print them, or maybe we call a method, but I'm just going to say dot, dot, dot. Okay, so here, if I'm, let me change this. So here, I'm using the equality operator to ask if D1 is equal to D2. Because the values stored in D1 and the values stored in D2 are memory addresses, this is known as memory equality. I'm asking if these two reference variables are equal in terms of memory. Are they holding the same memory addresses? So for reference variables, this kind of check for memory equality is actually asking, are these two variables aliases of one another? Okay, so to summarize, when you apply the equality operator to reference variables, you're asking a question about memory addresses. Are these variables storing the same memory address? In other words, are these variables aliases? However, oftentimes with reference variables, there's a second type of question we often want to ask, and that is not a memory question, but we want to ask, are the objects referred to by these reference variables the same? Okay, or are the objects referred to by these reference variables, do they have the same state? So that leads us then to the equals method. When I showed you the documentation for my die class, there was an equals method. And the equals method checked if the two die, this die and the other die that you pass in, if they have the same state. Okay, so really quickly jumping back. So this returns true if both die have the same number of sides and the same face value. Okay, so that was my equals method that I wrote. So the equals method checks if two objects have the same state. Okay, so I could say die D1 equals new die, and then I could set its face value to 5. And then I could say die D2 equals new die, and I could set its face value to 5. Okay, in this case, if I was to say D1 dot equals and pass in D2, this is asking if they have the same state. Okay? So to summarize, when you are working with reference variables or when you're working with objects, there are two types of equality questions you could ask. Memory equality that uses the equals equals operator, or state equality that uses the dot equals method. Both of these return Boolean, so both return true or false, but they're checking two different things. This is checking if they're aliases of one another, the reference variables. This is checking if the objects have the same state. Okay, so just to drive this home a little more, I want to end with an exercise. So here is a piece of code I've written, and the question is, what code can we write to get all 4 possible print statements? So you'll notice down below, so I've created 2 die here, die 1 and die 2, and then I have some conditionals. So first I'm asking if die 1 equals die 2. Okay, so I'm checking if die 1 and die 2 are equal using the equality operator. If this returns true, then I'll print out yes, they are equal according to the equals equals operator. Otherwise, I'll print out no, they are not equal according to the equal operator, the equality operator. Then I'm going to do the same thing, but now I'm going to call the equals method. So Boolean are the same equals die 1 dot equals die 2. So again, this method checks whether the 2 die have the same number of sides and the same face value, and it returns true or false. That answer is going to get stored in here. If the answer stored in here is true, then we'll print out yes, they are equal according to the equals method. Otherwise, this prints out no, they are not equal according to the equals method. So what this means is that when we run this piece of code, there's 4 possible outcomes, or there's 4 possible things that could be printed. We could see yes and yes. So yes, they're equal according to the equality operator, and yes, they're equal according to the equals method. We could see yes and no. So yes, they're equal according to the equality operator, but no, they're not equal according to the equals method. Okay, similarly, we could get a no yes printing out and a no no. Okay, so no, they're not equal according to the equality operator, and no, they're not equal according to the equals method. Okay, it's kind of a long explanation, but basically the question is, what code can you write here to trigger each of those 4 possible cases? Okay, so what code could you write to get a yes, yes? What code could you write to get a yes, no? What code could you write to get a no, yes, so on and so forth. So I want you to actually take the time to do this. So you can either code it up, although you don't really have to. it'll probably make more sense just in your notebook to write out 4 little chunks of code, right? Each chunk of code should trigger one of the 4 cases, and then bring this to class, and this will be one of our in-class problems. Okay. Okay, that is basically it. So let's just do a quick recap. So basically the assignment operator does what it does, regardless of whether it's primitive or reference. Here we have 2 very similar pieces of code using the assignment operator, one with primitive and one with reference variable type. And we see that the behavior is quite different, not because the assignment operator is different, but because primitives and reference variables store quite different things. So we see that with primitive variables, right, to change one is not to change the other. They both have their own copy, but for reference variables, to change one is to change the other. And that's because although they each have their own copy of the memory address, the effect of that is they're both pointing to the same object. And this is what it means to be an alias. Then we saw that with reference variables, we also have 2 different ways to check for equality and maybe 2 different types of questions we might be interested in asking. The first is asking if 2 reference variables are aliases using the equality operator. The second is asking if the objects referenced by 2 different reference variables have the same state, and that is the equals method. These are kind of related questions, as you'll see when you solve this problem, but they are truly 2 different types of questions that we might be interested in asking. Okay, so that is that. You should go ahead and try and solve this problem. It's one of the in-class problems, and then we'll talk about the answer in class. And I think we're done.